Hello everyone. Today we will discuss about the thermodynamics, the state functions and the path functions. What is state function? State function is a property of thermodynamics system which has a definite value for a particular state of the system. It is independent of the manner in which the state is reached. Examples are pressure, temperature, volume, internal energy and entropy. So these functions don't depend on the manner in which the change is brought about. These function depends only on the initial state, the difference between initial state and final state. And the other functions are path functions. These are the state variables which depends on the path followed are called path functions. These depend how the change from initial to the final state is carried out. Example, work and heat. So work and heat are the examples of path function because they depend on the path in which the change is brought about. First law of thermodynamics. What is first law of thermodynamics? The total energy of the system and its surrounding is constant, although it can be transformed from one form to another form. So the total energy remains constant. We can only transform from one form to another form. If energy in one form disappears, it will make its appearance in an exactly equivalent quantity in another form. So total energy is conserved. Mathematical formulation of first law of thermodynamics. Suppose a system absorbs a quantity of heat Q and its state change from A to B. This heat is used up in two functions. First, in increasing the internal energy of the system. If the energy of a system in A state is EA and in B state is EB, so the increase in energy will be equal to del E, which is equal to EB minus EA. So heat can be used in increasing the internal energy and to do some external work W by the system on its surrounding. So heat can be also used in doing some external work by the system. From the first law of the thermodynamics, we get that heat absorbed by the system is equal to increase in its internal energy and work done by the system. The heat absorbed by the system is equal to Q and increase in internal energy or change in internal energy is equal to del E and work done by the system is equal to W. So we can also rearrange this equation as del E is equal to Q minus W. Del E is change in internal energy, Q heat absorbed by the system, W work done by the system. This equation gives the mathematical form of the first law of the thermodynamics. Q is positive when heat is absorbed by the system, Q is negative when heat is given out by the system, W is positive when work is done by the system, and W is negative when work is done on the system. Energy change in an isolated system. You know that in an isolated system there is no exchange of heat from its surrounding, so absorbed heat Q is equal to 0. From the first law of thermodynamics, we know that D is equal to dQ minus W. dQ here is 0 because there is no exchange of heat, so dE is equal to minus W, or we can say dE plus W is equal to 0. It shows that the work is performed by the system on the cost of its internal energy. Energy change in cyclic process. What is cyclic process? If a system returns to its original state after performing many processes, it is said to be have performed cyclic process. Total energy change in a cyclic process is zero. So daily is zero. If we put the value of daily in first law of thermodynamic equation, then we get Q is equal to W. So the heat absorbed by the system is equal to the work done by the system. Here are the various thermodynamic processes. First is isothermal process. A process is known to be isothermal if the temperature of the system remains constant during each stage of process. For isothermal process, dT is equal to 0. It means change in temperature is equal to 0 because the temperature remains constant in isothermal process. If temperature remains constant, then dE, it means change in internal energy is also equal to 0. The second is isobaric process. A process is known to be isobaric if the pressure of the system remains constant during each stage of process. So we can say here pressure remains constant, and for isobaric process dP is equal to 0. Another process is isochoric process. A process is said to be isochoric if the volume of the system remains constant during each stage of process. Example, combustion of any substance in calorimeter. If we combust any substance in calorimeter, here the volume of the system remains constant. So it is an example of isochoric process. And for isochoric process, dV is equal to 0, and we know that W is equal to P dV, and here dV is equal to 0. If volume remains constant, then work is always 0. Adiabatic process. A process is said to be adiabatic if no heat enter or leave the system during the any stage of process. For adiabatic process, Q is equal to 0. Cyclic process. If a system returns to its initial state after a chain of process, it is said to be in cyclic process. Reversible and irreversible process. Reversible process, a process is carried out infinitesimally slowly so that the driving force only infinitesimally greater than the opposing force is called reversible process. And irreversible process, any process other than reversible process, that is which does not take place in infinitesimally slowly, is called irreversible process. So this is the today's chapter, which is over now. Please like, subscribe, and view the video.